Have you ever just stopped and really looked at the world around you? I don't mean the natural world, but the one we've built. You know, the roads you drive on, the bridges you cross, the buildings, the pipes that bring clean water right to your faucet and just whisk away the waste. It's all part of this massive engineered reality, and it works so well that most of the time, we don't even see it.
But how did we get here? I mean, really, how did humanity pull off this incredible leap from being these small, scattered groups of people to a complex, interconnected global civilization with billions of us? It's one of the biggest questions of our entire history, and the answer isn't just about politics or money.
Hello, everyone. Welcome to Connect and Build. Sit back, relax, and enjoy the video. Let's get started.
The answer is literally all around us. It's written in the steel, the concrete, the systems that make our lives possible. It's in the curve of a highway, the massive span of a bridge, the impossible height of a skyscraper. The hidden hand behind all of it, that's civil engineering.
So to really get what this is all about, let's rewind. Way back to 1828, the Institution of Civil Engineers came up with this amazing definition: the art of directing the great sources of power in nature for the use and convenience of man. I mean, think about that. It's not just about building stuff. It's about harnessing nature itself, rivers, mountains, the very earth, and shaping it to help humanity. It's this incredible meeting point between us and the natural world.
Okay, so how does that grand old-school vision actually work today? Well, this chart breaks it down perfectly. You can look at it in a couple of ways. First, there's the phase of a project. Are you planning it, building it, or keeping it running? Then you've got its purpose. Is it for water, transportation, or buildings? So, for example, if you're planning a new water system, you need hydraulic engineers. But when you start building it, you're going to need environmental and geotechnical experts. A single huge project, like a new high-speed rail line, is going to call on pretty much everyone on this list at some point. It's a huge, coordinated dance. To really understand this field, we have to go back to the beginning. Let's start with the absolute most basic problems humans had to solve: finding a permanent place to live and getting enough food and water to survive.
You know, for thousands and thousands of years, we were wanderers. But then, this revolutionary thing happened. Somewhere between 4000 and 2000 BC, we started to settle down. And this created a brand new, massive problem. How do you build a community that can actually last for generations, especially when you're in a tough spot, like the dry lands of Mesopotamia? Well, the Sumerians, in what's now Iraq, they came up with some of the first big answers. They needed a central point for their new cities, right? A cultural and religious anchor. So they built ziggurats. These things weren't just buildings, they were enormous, tiered platforms, some of the very first large-scale structures ever designed to be permanent. It was a statement. It said, "We're here, and we're not leaving."
But a city needs more than a cool building in the center. It needs food. And this is where the Sumerian genius really shines. They engineered these incredibly intricate hydraulic systems. We're talking canals, dams, reservoirs, the whole shebang. They figured out how to control the flow of water, turning this dry, difficult land into fertile farmland that could support thousands of people. This was basically the birth of hydraulic engineering, and it's what made cities possible in the first place.
Okay, so humanity's figured out how to build cities. What's the next big hurdle? Connecting them. Once you have a bunch of cities, the problem isn't just surviving in one place. It's about conquering the huge distances between them.
I mean, think about it. If you're running an empire, how do you govern a territory that takes weeks, even months to cross? How do you get your army to a border to defend it? How does trade even work? Suddenly, distance becomes the main thing holding you back from growing.
And nobody, I mean nobody, solved this problem like the Romans. Their solution was just brilliant: brute force engineering, a 50,000-mile network of roads that stitched their entire empire together. And check this out for skill. The Appian Way, their masterpiece, was built in 312 BC. They used massive lava blocks on top of crushed stone, and parts of it, people are still driving on them today, over 2,300 years later. That is engineering that was built to last.
You know, the tech has obviously changed a lot, but the basic idea, it's exactly the same. Today, we're still solving the problem of distance with networks. We've just cranked it up to 11 with these complex highway systems and high-speed rail lines that don't just connect cities, they connect entire continents. A Roman engineer would totally get what we're doing. But here's a wild thought. What happens when an engineering idea is too good, so revolutionary that the technology of the day, or maybe even people's imagination, just can't catch up?
So get this. In 1502, the one and only Leonardo da Vinci proposed this bridge design. It was for a single 720-foot span, with this elegant flared base and a pressed bow arch. I mean, it was breathtaking, but the Ottoman Sultan he showed it to, he thought it was impossible, so he rejected it. And for 500 years, it was just a sketch in a notebook. But then, in 2001, a smaller version was actually built in Norway, proving that da Vinci's design was totally sound the whole time. He wasn't wrong. He was just 5 centuries early. Incredible.
So, after connecting the world horizontally, the next great engineering challenge was vertical. As our cities got more and more crowded, well, the only way to build was up, and that required a completely new way of thinking.
Right, the skyscraper didn't just pop into existence. It stands on the shoulders of some key innovations. Each one of these steps made the next one possible. First, in 1824, you get Portland cement, which suddenly makes concrete construction cheap and easy. But concrete is amazing when you squeeze it, but terrible when you pull it. So about 30 years later, engineers figure out you can embed steel rebar inside it, giving concrete the tensile strength it was missing. Total game changer. Then, fast forward to the 1960s, and an engineer named Fazlur Rahman Khan develops the bundled tube design, which was this revolutionary way to make tall buildings super stable against strong winds.
And all of that history, all those breakthroughs, lead to this, the Burj Khalifa in Dubai. To get that high, engineers had to invent yet another system. It's called the buttressed core. So picture a hexagonal center with 3 massive supports coming off it in a Y shape. This design is brilliant because it provides stability from multiple directions, which basically confuses the wind. It stops powerful wind currents from getting organized and causing the tower to vibrate or twist, something that is absolutely crucial for a building that tall.
So we've seen how civil engineering solved the massive problems of the past, but what about tomorrow? The challenges that engineers are facing today are, in a lot of ways, way more complicated than anything we've ever seen before.
The whole focus is shifting. It's not just about building bigger or taller anymore. Now, the cutting edge is in materials. Things like self-healing concrete, or using nanotechnology to make materials that are way stronger and lighter. It's about resilience, designing our world to withstand more extreme climate impacts. It's also about sustainability, figuring out how to adapt and reuse our aging infrastructure instead of just tearing it down. And of course, it's about using insane amounts of computing power to design and test structures we couldn't have even imagined just a few years ago.
And all of this leaves us with one final big thought. You see, for most of history, civil engineering was about making life more convenient. But now, as we're facing enormous challenges like climate change and a scarcity of resources, the mission itself is changing. So the question for the next generation of engineers isn't just, what can we build? But how can we build a world that can actually endure? The next chapter of this story, well, it's being written right now.
Like, share, and subscribe to Connect and Build. I have already done. Did you guys subscribe?